The constant chop will allow us to create channels at a constant value. We can add a second channel by typing in here and then setting that value, and then we can also go to the channel tab to make a channel have an interval over a certain period of time. We can then snap incoming channels, so if I lay down an LFO, we can snap that channel at its particular point by clicking the snapshot input button. The LFO chop will allow us to create waveforms. So here we have a trail, and what we can do is we can choose whether we want to have a sine wave, a Gaussian wave, or a triangle. And we also have a ramp, so you can see that there, and a pulse and a square as well. We have a play parameter which will allow us to play or stop at that specific area where the line already is. And we can also use a frequency, so we can slow it down or speed up the frequency so we get more per second or less. And we also have an amplitude, so we can decide whether we want it to be from -1 to 1 or from, say, -4.43 to 4.43. The noise chop will allow us to create noise, so we can, for example, use sparse, Hermite, or different types of noise here. So if we stick with sparse, we can change the period here, so we can see how that's affecting the wave. We can change the harmonics, which will give it that sort of smoothness or that rougher look to it. The roughness will just sort of decide how jagged the peaks are, and the exponent will kind of decide how it moves exponentially, it sort of grows, and the amplitude will decide what sort of amplitude we want over that period. So we can move the noise by middle clicking and dragging left and right under the transform tab, and we can also decide on whether we want more than one channel. So if we open this up and say channel 1 to 10, then we can add 10 channels, which we can see. And we can also, if we want, time slice, so we only have one sample rather than the larger number of samples that we had before, and it will animate over that time. So we can add a trail and we can see that we have 600 samples there. If we add a trail, we can see the noise animating. The select chop will allow us to place an input into its input there, and we can then select a channel from the chop which we've input. So we can use, for example, channel 1, or we could use a star, which means all, for the asterisk. If we wanted to not choose channel 1, then we could place a caret here, and it would choose all channels but channel 1. So there we have channel 2 and channel 3. And we also have the ability to reference rather than using an input. So if we reference a null by dragging this null up to its chop parameter, then we've now referenced that null and we've chosen channel 1. We could add a second channel into that chop, and we would then basically decide between channel 1 or channel 2. The math chop will allow us to make mathematical operations on our chops and channels. So for example, if we combine channels by adding, we can add the first channel and second channel of the first chop, and we can add the first channel and second channel of the second chop to make that second channel. If we turn this off, we can also combine chops by multiplying. So if we have 1 multiplied by 2, we'll get 2, so we have channel 1 multiplied by channel 1 and channel 2 multiplied by channel 2 to create the first and second channels. We have pre and post operations which will allow us to, for example, negate, which will mean that we have -1 multiplied by -2, so we won't see any effect if we make it a pre-operation. However, if we negate as a post operation, we'll see that we've now multiplied by -1 after we've made our initial combination. We can create an integer by using ceiling, so we've rounded to the highest integer. Floor, we round to the lowest integer, and round will just round to the nearest integer. We can multiply by using, for example, 2 there. We can just multiply our channels, and we can multiply by 0 if we want to zero them out. And we also have post-add and pre-add, which will allow us to add a number on before the multiplication or after. We then have a range, so we could say from range 0 to 1 to 0 to 10, and we'll have a much higher number, or we could even say -1 to get the negative values. The lag chop will allow us to lag a channel. So for example, here we have a slider, and we're lagging it by 0.2 over each second. So we can see an arc there where the lag is taking place on the line. So if we set our increasing values, which is the left parameter there, to 0.5, and then we have decreasing at 0.2, we can see as the decrease is much tighter than the increase. We can also overshoot, so we could overshoot by 0.2, or maybe even more. Actually, we'll say 1 and 1 in the decrease there. So now we can see that it overshoots, it comes back, and it sort of just makes its way back to that 20, which is the maximum we have on our slider. We could also do this with a decrease of the slider as well. The speed chop will allow us to convert our time into distance. So for example here, if we bring this constant up, we can see that it starts counting up dependent upon this value. So if this value is 1, we'll count up 1 every second, whereas if it's less than 1, we'll count up slower. So in our speed we have a reset parameter, so we can reset using this button in the speed chop itself. And we can also use a reset input as the second input. So if we lay down a constant here, and then you set that to 1, we can see that it resets that speed chop each time it hits 1. We can also limit the speed, so we can clamp the speed from 0 to 1, and what this means is that when we reset, it will count up to 1 and then stay at 1, which is useful for any sort of ramps that you want to create. We can loop, so we can say from 0 to 1 and then 0 to 1 again. And we can also use zigzag, which will go from 0 to 1 and then from 1 back down to 0 again and keep repeating. We can see that a little bit more obviously if I give it a larger number, maybe 5. We can see it starts counting back down. The beat chop will allow us to create a ramp which is tied to the beats per minute on the timeline. So here we have a tempo of 120, we can put this up to 240, and we can see that our beat has doubled there. So we can set that back, and we can also change the timing signature, which is not quite so obvious yet, but if I make a few modifications then we can view that more obviously. We have the period, which is currently at 8 beats per bar. If I just click that, so we can hit the down arrow and choose how many beats in the bar we want. So there's 1 beat in a bar, 4 beats in a bar, and we can change how many bars we want, how many multiples of ramps, and we can also offset those slightly, so we can see there we've offset the ramps in time. And we can also offset randomly as well, which just gives a little bit of randomness to the beats themselves. We also have the output tab. This will allow us to show the bar and show the beats, so we can actually see the beats counting up and then the bar counting up after that. So we can see there we get 3 beats and then we have another bar start. So if we went down here and changed our timing signature, we can see that reflected in the bar and the beats. Finally, we can also use, instead of using this timeline, we can go in and add another timeline by using a component time. So if we right click and click add component time, then we've created a component with its own timeline attached. So we can see here that we have this component with a tempo of 120 and a signature and it also has a number of frames and the frame rate and whether that timeline is playing or not. So we can attach that to the beat by, under the beat tab, dragging it to our reference node. And now that beat will be running from component time rather than the main timeline. We can change our component time and then view that by clicking on the local component here, and then opening up the parameters, and then changing the tempo, and we can see it's doubled in pace. So this is completely independent of the main timeline. The lookup chop will allow us to use an index input and a lookup table input, and basically we can cycle through the lookup table, which is this wave here, and all of its samples using the index. So if we take this channel and move it from 0 to 1, we can see in our trail here that we've actually selected the certain area or certain sample which we want to choose from that wave. So we can cycle through and see that we're getting the same sort of wave, but we're manually moving through. The trail chop will allow us to take a channel and then take a window of time in which we want to trail it. So for example, here we have an LFO coming in from -1 to 1, and we're trailing it over a window length of 4 seconds. So we can change that by clicking up here and choosing 2 seconds, for example. And that will then half that, so we now have 2 seconds of time. We could also use frames or samples, so for example here we can change the samples to 60 samples in a second. The record chop will allow us to take our input and then record it over a period of time. So here we can see that we've recorded over the full range, but we could also set that to segment, which would allow us to record a certain number of seconds, so for example 10 seconds here, and we can move our slider and we can see that moving around. We could also add in input, so for example we have our active input, which will allow us to play and stop the record. If I just turn the record to auto range there, and then if I disconnect this, as it shouldn't really have connected twice. There, so now we can basically set this constant from 0 or 1, and 1 it'll play and 0 it'll stop. And then we can move our slider dependent upon whether it's playing or stopped. The final input is our reset, so if I just input here another constant, then we can see the reset. If I just play it as well, it might help. And then move the slider a little. And finally, we can reset that channel. The limit chop will take an input and then limit it. So for example, if we choose to clamp, then we can clamp with a maximum of 0.5. And we'll see that this channel here in the trail will never hit greater than 0.5 as it's clamped off. We could also set our minimum, so -0.5, and then we can see that it's getting clamped between those two values. Positive only will mean that the wave does not go below 0, and we could also use a loop, which will just loop back on itself rather than clamping, or zigzag, which will do a similar sort of effect. So if we turn off our limits, we can also quantize, which will allow us to create a stepped effect. So if we set a ceiling of about 0.5, so 0.5 there, we can see we've stepped the wave. The merge chop will allow us to take 2 chops and then bring them together into one. So we can, for example, take this constant 1 and we can just wire that into the merge one, and then we'll see that we have chan 1 there, which is the same channel as the input. If we take this second constant, we have chan 1 again, so we have 2 channel 1s, so this would become in and be renamed to channel 2, as we can't have two channels with the same name. We could switch these channels around so that channel 1 becomes channel 2 and channel 2 becomes channel 1. So we can see there they've switched. And we could also, if we wanted to, just switch them back, and we could, rather than having them both in there, we could also say keep the first or keep the last channel. So we can keep the first, keep the last, or we can make unique, which will add both. The panel chop will get the panel values from a component. So for example, if we have this slider here, if we middle click, we can see all the panel values there and as they move. And here we have them in the chop format, but we don't have a component selected. We just have the project 1 component selected. So if we just drag this slider, then this slider is now the component we're using, and we can decide on the channels we want. So if we just select U and V, which is our X and Y, and if we then rename those, so we can rename horizontal and vertical and vert, so we have two channels there, and then as I make this active we can see we can get those channels into our panel chop. The MIDI in map chop will take in MIDI data from one of our devices, which is mapped in the MIDI device mapper. So we can see we have sliders and buttons which we can select in the device ID, and we can add a device by clicking dialogues and then going to our MIDI device mapper. And we can see here that we have no mapping, so if we add a device mapping, we can choose an in device. I'm going to use a Nano Control, which I have plugged in, and we can see the control changes coming in there as I move the slider. And we can also choose, for that, we can choose a MIDI map. So if I go to devices, I can add my own MIDI map. So if I add a device, then we can rename this to Nano Control, and we can begin to edit our device mapping. So now that we have this, we can see that we have our different sliders coming in. So we have B002 is our first slider that I'm moving around. So let's type in B002, and then if we just make that the map under the device mapping. So now that this device is mapped, we can exit this and we can see that we have our different sliders here in the chop. In our channels, we have a device ID of 1. If we don't make sure that that's the same as your ID, otherwise you won't get the right data. So if we then move the slider, we can see the channel is moving along with the slider, and that's because this is the only slider that's mapped. So if I move slider 2, nothing will happen as it's not been mapped yet. So we can continue to map different sliders by choosing the different sliders, and we also have buttons here which I'm hitting, and you can see in the bottom there, and we can map those using the buttons tab. The OSE in chop will allow us to bring OSE data from a device. So for example, I have an iPad which I'm going to bring data in from. We have a network port here of 10,000 which we can use, and if I open up my command prompt, I can type in ipconfig, and this will give me my IP address, so I know that my iPad has to connect to 192.168.0.7 on the network port, which is 10,000. So if I connect that and then start moving my sliders around, then we can start to see the data coming in. So this is an XY pad which I've brought in, and I have a fader there as well. And we can just keep adding, and as we move our sliders, they'll be brought in, and we can also reset the channels to set them back to the way it was before. We can use delete old channels, which will basically allow us to replace the next channel. So here we have the XY pad, and then I've just switched to another XY pad, and it's switching the inputs, so switching those channels to replace each other rather than adding on. We can switch to a fader there and then switch back to the XY pad.